Hey guys, welcome to shop. So this is just a simple project. This is basically about working the layout lines and starting to think a little bit three-dimensionally on a milling machine. So this is a set of soft jaws for a vise, and they are frankly really easy to make. You don't need to think that hard while you're doing it. I traced with a scribe and die chem and used a set of transfer punches. So I think laying them out took about as long as this introduction, and I want to say it was like 3/8 or oh god, 3/8 or 7/16 thick aluminum. I don't know. It was something I had in my scrap bin. One of the pieces already had holes in it, so I wasn't worried about it. Uh, since this is aluminum, I'm using a 2 flute end mill. A 3/8 end mill will do a lot of work in aluminum. You don't need to go to a huge, 5/8 or 3/4. I know people do. I don't really feel like I get that much more work done with them than a 3/8, and the 3/8 are really cheap. Also, if this is you know, introduction to running a milling machine, that little lever you see just above the spindle vertically, that is the lock. Make sure that's locked when you're milling and unlock it when you want to drill. You do that because the quill will actually get sucked down as you cut. And for side milling, not necessarily a big deal if there's not a relief on the bottom. And you'll notice when the collet is rammed into your part, and it's just lock whatever you don't want to move, lock it. In aluminum with relatively light cuts with this, I actually might leave the y-axis unlocked, but with my hand on the handle. So if it does start to grab and move, I know to back off and I will lock it or just take a lighter cut. Normally in steel, I will lock whatever axis isn't moving. You can leave whether or not to lock the knee depends on how precise you want to be, because a locked knee will move your x and y axis. The everything moves when you lock it. Sometimes it's like half a thousandth, sometimes it's a full thousandth, depending on where. On my machine, it's pretty consistent between 3 to 7 tenths. I think it's about 7 tenths on the knee and 3 tenths on the X and Y. I might be wrong. I tend to just check with an indicator that day because I can never remember, or the DRO. It's something to be aware of if you're trying to be super duper precise, because everything moves, and by the nature of it being able to move, you have some clearance that gets taken up. Now you can see here, I'm trying to conventional mill as much as possible on this because I don't want to shoot. I don't want to break anything, but also I'm trying to shoot the chips off to the right as much as possible. So I will climb mill a little bit. I mean, I think I just said to heck with it and climb milled here because it's aluminum, and I probably could even crank faster than I am, but steady, even pressure. If you go too fast, you get kind of a crummy surface finish, which again, soft draws doesn't matter. Just go have fun, make some chips, don't crash the machine. But you see this huge burr that's about to fall off and plop on the table there. That's because the aluminum's smearing ahead of time. I don't have the RPM for this small of a cutter, which is really funny. I mean, it's aluminum. So pretty much as fast as you can run, that's how fast you should be running. It would be nice to have like 42 or 4500 RPM, but I don't. So we're going to work with it, and you deburr it real quick. I just use a file. I don't have an actual deburring tool because those cost money, and I have probably 30 chainsaw depth gauge files, which are going to work until I run out of them. And clean off the vise. If you're not sure if the vise is clean enough, stick your finger in there. If you don't feel any grit, then it's clean enough. Or a white rag. I use my finger. My hands are tough enough now. I don't really get splinters that often, unless I'm side milling hardened steel. And you'll see, I can't really decide what height parallel to use, so we're just using a bunch of them. And this piece, I think I needed to take off a little bit more material than the other one, or a little bit less material than the other one. And by now I'm like, okay, I'm gonna do. I'm trying to remember if I was doing a full width step over or not. A good rule of thumb for side milling is use 40% of the width of the cutter. 50 to 60% is kind of a no-no. It tends to deflect and snap the cutters more, in my experience. I can't remember who told me that, but it was someone who really knows what they're doing. And I always try to do 40%, whatever, uh, 30 to 40%. So, like a third in your head, a third of whatever the end mill diameter is. So, say with a half-inch end mill, 160 thousandths is good. Or in this case, I'm just like, doing a little more than half a turn on the handles because it's 200 thousandths per inch. And my step over here is mostly just so I can maximize feed. So precision doesn't matter. And I'm not even using the dials because we have layout lines. We've got layout lines and center punches. And I don't even use a wiggler for the sake of time. I just kind of eyeball the center, the center punch because it's a clearance hole. There's plenty of room. The holes themselves, I want to say, I think I used a letter drill bit, a letter I drill bit, and it was a 5 or 6 millimeter screw. So they're really rattling around in there. I could be a 16th of an inch off and it would still work. So that's another thing. Like, depending on how precise you need to be, you can just eyeball it and send it. And you see here, we are conventional milling, and conventional versus climb in aluminum in a machine this size and end mill this small. It really doesn't matter. Just cut the way that's convenient, shoot the chips away from you. And you can see we make a lot of chips really quick. It's not like steel, where that much material removal would take 20 or 30 minutes. And we did all of that material removal and a couple different setups in less than 7 minutes. And you see also the wood I placed on the top of the table makes it cleaner. And I know a lot of people say, oh, well, you just use an air gun, but the air gun makes a lot more cleanup on the floor. So I think it's actually a waste of time. So I just brush all the chips off with that little chip brush, or I have a bigger benchtop sized brush. You can see here, I'm like, okay, one's a little taller than the other. I'm going to put the shorter or taller one back in. I'm going to nibble off the top. And I want to say I actually got these pretty close. It's probably within 5 thousandths, which is pretty good for layout lines, especially being lazy. But I will tap it down on the parallel. There's only a single parallel in there. And we're just going to hog it off real quick. The milling machine go burr. I would say if you're a hobbyist and you're running a much smaller machine than this, even in aluminum, don't do a lot of the things I'm doing. Pay attention to climb and conventional milling. Where I know a lot of people are using the smaller Precision Matthews benchtop machines seem to be really popular. They seem to sell better than the Grizzlies, at least right now. Um, I don't know if you can do stuff like this or not on those machines, and I would recommend being careful about it because they are small machines. They just because they have a good spindle, the lead screws on them are much smaller than a full-size Bridgeport. And I'm reasonably certain just the table, not even the table and saddle, just the table weighs the same as some of the really small benchtop machines people are buying. So, like, just to give you a sense of scale, on some of the smaller machines, my vise wouldn't fit in their work envelope. So on something like that, you've got to be more careful. And also, I don't have a quick collet changer. I don't have basically an impact gun that bolts to the top of the head. Those cost money, and you see here, just before I'm even thinking about it, I swap out and go to a drill chuck, and I have unlocked the quill. So now I can drill, which that's good. I don't know if you can really damage something unless you're a complete oaf and pulling as hard as you possibly can on that. And I don't bother to use the power down feed either in something like this where it's like it's 4 holes and it's a soft material. It's nothing really matters. I don't worry about grabbing too much in aluminum. It's not a material that grabs. It's not like brass, and it doesn't have the resistance to cutting that steel does. I'm like, screw it, we're ramming. I still peck just because I don't like the really long stringy chips that wrap around everything. I've had them bird's nest and cut me, and I don't like going to the ER. Also, I don't want them to reach around and smack the camera, which I have knocked my phone off the camera tripod before with chips. I forget what I was drilling, but I think I walked away on something under power feed and just bopped it off because it's not that steady. My floor is so heaved that even though it's on a tripod, the tripod legs don't adjust enough, so you can see how it just rocks if I even tap it. And I mean, it'd be really nice to get the shop nicer and get some better camera equipment, but I think that's not going to happen until I'm monetized. I'm going to keep uploading in 720 because my internet's terrible here too. So, you know, if you want better shots, send me something, but I don't think it matters enough. We're really here to learn, not focus on the highest production quality. At least I am. So, what's cool with this keyless chuck is you can see how quick it is to change tools. And I'm kind of casual about it where you'll feel it as soon as it stops. You can grab it and unlock it really quick. I don't know if that's the best idea, but there's really nothing to grab onto your skin on a keyless chuck. So, especially when it's under braking with the VFD. So, if you actually do apply a load to it, it just stops even quicker. At least the way mine's programmed. So, it's like, not a great idea depending on the machine you have. But I haven't gotten hurt doing it. Probably as soon as I skin my hands, I'll stop doing it. And you also notice I do have a wrench to tighten this more. I don't need the wrench on my chuck 99% of the time. This is actually pretty good. They're inexpensive. I believe I bought this off Amazon or eBay. I cannot remember. Basically, all of their Chinese tooling is pretty interchangeable, and I wouldn't worry about whether you bought it from Amazon or eBay because they're probably the same vendor originally. Here we are. You see, I'm just banging over on this, not even using the DRO. I'm already centered on that hole. We're just going to go to what looks like the right depth, and that's the depth I'm going to go to. And I sort of used my quick adjust drill stop, and I actually felt like that was kind of dumb. After this hole, I just eyeballed the depth. Again, we're working the layout lines, guys. Like, if this is your first project with the milling machine, this is a good idea to just kind of learn how all the functions work, because we are drilling and we are milling and we're moving in a few different axes. And when you're using a milling machine, you kind of got to think three-dimensionally, even when you're doing drilling, because the knee moves up and down. And it's kind of wild to me. I guess it really shouldn't be, because so many people are used to a drill press, and on the surface, this is just a drill press with extra features, but it's really not. It is so much more capable than a drill press could be, because it's got a true spindle, not a quill. And I think the difference between a spindle and a quill is that a spindle can take side load. So that's just a difference. And I mean, you saw my Dum Dum's guide, like, you can tilt the head on this, and actually, even though I can't nod the machine, I can still do compound angles on it by rotating the whole turret and tilting the head. So, you don't necessarily need nod on a machine to do stuff like that. While nod is really nice, and I think a turret mill for a shop like mine, with, generally speaking, like, I don't remove more than 8 ounces to a pound of material from something. So for me, the lack of rigidity that comes with the turret mill is really nice because you can do goofy things on it that you couldn't do on even just a regular knee mill. Like I don't I don't know if nod is strictly necessary. My next machine is going to have nod. I'm keeping this machine probably for the rest of my career. It's in good shape. I won't wear it out with care, but I think nod is really nice for certain jobs, but it is really nice on this because it doesn't lose tram very easily. You know, if you're doing all your hogging on the y axis and you don't have a lot of lateral load on the ram, I'll only have to retram it, but like every couple of weeks if I don't deliberately not take it off, and I'm almost always within 1 or 2 thousandths. Where with the later dovetail rams, if you break one end mill, you'll knock it loose. They're relatively delicate machines. You see here, I'm just eyeballing up the next hole, and by now I've gotten the rhythm. So it's there's upsides and downsides. I think the newer Bridgeport clones they have better locks than the actual Bridgeports. They're not always as well made, but being the best made machine isn't always necessary because I don't think manual machines see the hours they used to, so they're not getting worn out like they used to with care. And a lot of people, I think, don't lubricate their machines or have a good lubrication schedule. Even with the one-shot oilers, you need to be aware that they might not be delivering oil because a little bit of dirt will clog the lines. Now, this machine still has Zerks, so I use an oil gun and that's not a concern. But, the discipline of lubricating it every time you use it is a little bit easier when you're the owner-operator and you've had to pay bills on repairs. So that's one thing, like, I do, if you have employees or you're a really busy shot and it's easy to or shop, not shot. One shot oiler is probably worth the money to you, but that's kind of a you decision. I think for me, I would like a one shot oiler, but I don't want a one shot oiler bad enough to replace the fittings on this when it works. And the vise comes on and off enough that I can just oil through the table or oil through the side of the table to get that nut in the middle. It even if you're oiling that every week or two, that's still way better than most places, and you'll get a good life out of it. Your brass nuts are consumable, and they tend to wear not the lead screws. What I actually will do once in a while is I will convince someone to crank the table, and I'll crank the table, hold a string, and clean all the grit out of there. I do it on the lathe pretty regularly. Just keep everything clean; it lasts longer, and it feels nicer too. So we're just going to cut over to screwing these jaws in a few moments to the vise and a little explanation on why we do it. But soft jaws are just nice if you're holding finished metal parts that you don't want finish damage on. So here we are back over at the vise. The jaws are basically finished up. I've just got to screw them on and clean them up. So this was a quick project. I think we're about 20 or 25 minutes in. They're not perfectly symmetrical, but they are usable, which is what matters. Now it's just, I kind of got tired of these. I mean, one of them's counterbored a little bit deeper than it should be, but whatever. Unfortunately, these are not 732. And they're not 6mm. I think we'll have to make it work with 3/16, which I know isn't the right size. They are metric screws. So, I mean, that's that. That's just a quick, I guess, 20-minute, 30-minute shop project, however long it's been since I started. I haven't even kept track. And, you know, I didn't even bother trimming this front one to length. I don't think it actually matters. Just knock the sharp edges off. Knock another file on the ground. I mean, overall, really not a hard project. Pretty good. Quick beginner project. I mean, you can just work to layout lines. I mean, you saw me not even try, and I'm not even trying to chamfer this on the mill because a chamfer isn't critical. It does not improve the functionality of the jaws in the slightest. So there's no reason to invest the extra effort. And if this really bothers you, well, I'm sure you'll survive. I don't see the point in matching them up. These are a consumable item that wear. So I might be replacing these in a month, maybe 2. So I'm not gonna make them pretty. I gotta make them work, and these won't chew up metal parts that got clamped in there like the steel ones would. Thanks for watching, guys. I hope you enjoyed.